Hey everyone, welcome back, and today let's solve Leetcode problem 200 titled Number of Islands. So we're given an m by n 2D binary grid which represents maps of ones or land and zeros or water, and we have to return the number of islands. So an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. And we may assume that all four edges of the grid are all surrounded by water, just for the loss of generality. So in example 1, we have the input grid to be a 4 by 5 matrix, right? Where ones, again, represent land and zeros represent water. We would output only 1 here because we only have one completely connected land, right? It's basically all these connected or 4 directionally adjacent ones that mark or represent land. So as you can see, we have the one starting from, or the island starting from any land you really want. I'll just start from here. As you can see, we'll go here, 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 and that's also connected here, here, here. And that's actually just one complete island. It may be large, but they're all connected via land in some 4 directionally adjacent cell, and so this is just one large island. And since we don't have any more land or any ones left in the other parts or cells of our input grid, we'd output only one island. So in example 2, we would output 3 islands in the same dimension grid because we have one island here of size, or area per se 4, if you will. We have one island of area 1, just alone here, an empty island, and we have one over here. So note that 4 directionally adjacent cells do not include cells connected diagonally, right? So these ones would not be considered part of the same island if they're not connected through a different cell or through a different path, right? They're not connected directly to each other because they're diagonal, not horizontal or vertical, as we saw in the problem right over here. So in example 2, we would output 3 islands for that reason, and for our constraints, we see that m and n are the length of the grid and the length of the grid at index I, and we know that the lengths at these variables or positions are going to be less than or up till 300. And we're also guaranteed rather that grid at any index I, any index j, is going to be 0 or 1. Basically, it is going to be a valid input of either water or land, and that really says that we don't have to handle any weird edge cases or base cases when we don't have a valid piece of land or water that we're looking at for one cell. So with that out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem. Okay, so if you guys haven't picked up yet, essentially to solve this problem, we'll use a graph traversal algorithm, probably either DFS or depth first search or BFS or breadth first search. And the idea is to treat each one as a node in the graph, and when we find a 1, we'll use our DFS to traverse all connected ones and mark them each as visited or part of our island. And each time we initiate a traversal, it indicates that we have found a new island. So we'll use of course, 2D grid as the input to process that input grid matrix, and we'll also use a DFS traversal to explore adjacent lands or cells that are represented by ones. And finally, we'll have a visited set to modify the grid directly to mark visited land. So to kind of just break this down a little bit more raw, we'll loop through the entire grid using nested for loops, and when we find a 1, we'll initiate our DFS helper function or algorithm to mark the entire connected component or the island. And after marking all connected lands for this specific island, we'll increment our island count, which is ultimately the variable that we want to return at the end of all of our levels or all of our cells as we DFS or depth first search all of those different cells for our different islands. So first we'll have our base case, which is quite simple. That essentially says if not grid, or not grid at index 0, not grid at index 0, we can immediately return 0. Okay? So essentially what this is saying is that we'll basically check if the grid is empty or if it contains no rows. And if that's the case, we can return 0 because there are no islands to actually count, right? And so we don't actually need any number we don't actually have any number of islands, and so it would be 0, right? There's 0 islands, or there's an absence of islands. If that's not the case, and we don't actually fall into this conditional for our base case, then we'll initialize our rows and the number of columns input in our input to be the length of the grid and length of the grid at index 0 respectively. Okay, again, what this does is we'll store the number of rows and columns of the grid into the variables row and columns respectively. And this basically helps us loop through the grid and balance check the indices or cell values later on for each search or level of our DFS algorithm. So once I do that, I'll actually define that DFS, in this case, helper function. That's going to help us traverse through and look through all the different islands for each land in our input. And for my parameters, I'm going to take, of course, 2 coordinates, or basically cell values, for every single cell to check if it is part of an island or not. So first I have to have my imbalance check, right? So basically it's going to be pretty long, but it's similar to how you guys have seen in other matrix problems like rotting oranges or word search, where essentially I have to check if the current row value or row cell value is less than 0, or the current row value is greater than or equal to the number of rows, or again, with similar approach or thought process, if the column value or column cell value is less than 0, or the column cell value is greater than or equal to the number of columns or grid at index R at index C, if that's actually equal to the string of 0, because note that all of these values, or lands and water, if you will, present in our grid are inputted as strings and not integers, which is also something very important to note. So if, of course, this is 0, then we immediately want to return, kind of like our base case in this DFS helper function. So again, what this does is it checks if the current cell, index R, index C, or cell value RC, is out of bounds, or if it's water, right, as denoted by 0. And if any of these conditions are true, we can simply return, stopping the DFS for this path, right? So if that's out of bounds, or that's not going to be equal to water, we can immediately exit the current recursive DFS call, right? If it's equal to water, or the current cell value or column value is outside of bounds, right? And again, similar to backtracking functions, this is our base case. And of course, if we don't actually fall into this base case or meet this criteria, we can mark grid at index R, at index C from water, check there should just be 1, to, from rather land to water, right? And once we do that, we can recursively call our DFS function for the 4 directionally adjacent cells from index R, index C, or cell RC. So we'll call DFS at R minus 1, C. We'll call DFS at R plus 1 C. We'll call DFS at R C minus 1. And finally, we'll call DFS, if you guys have noticed, R C plus 1. So again, to better explain these lines of code, first on line 10, what we do is, if the cell is land 1, or basically if it is land, we'll mark it as visited in this traversal or search by setting it to 0, or basically water. And this ensures that we don't visit the same land multiple times during the DFS traversal. And then we'll recursively call the DFS function in the 4 directions, up, down, left, and right, or all the 4 directionally adjacent cells of the current land to mark the entire island as visited, right, on lines 11 through 14. Okay? And that's honestly just basically it for this function, which we can call for every cell value of our input grid. And the way we do that is, first we'll initialize the number of islands we actually see to be 0. I'll call it islands to be 0. And ultimately, I have to return the number of islands once I'm done passing in this DFS function with every single cell as a parameter, right? So once I initialize that islands, then I'm actually going to loop through all the different cells in my input grid, and I can easily do that using the rows and columns variables. So I'll just say for R, basically an alias or symbolizing rows in the range of the number of rows present in my input grid. And then I'll just say C, in the range of the number of columns present in my input grid, right? Or basically rows and columns are the number of rows and columns in my input grid as I initialize on line 5, right? With the length of the grid and the length of the grid at index 0 respectively, where R and C, or row and column, are my two iterators. And now I actually have to check if grid at any index R, any index C, in this for loop or in this traversal of my input grid, if that's actually equal to land, or basically 1 for that cell value, I can not recursively, but I can actually call DFS at that cell value, or basically at RC for this iteration, and then I can increment the number of islands that I've seen. Is that how you spell islands? Yeah, I think so. By 1. Okay? So again, what this does is, for each cell RC, if it contains land, or basically 1, we'll initialize a DFS traversal from that cell because we've found an unvisited island that we haven't already marked to be water yet in this iteration. Then we'll actually call the DFS function to explore and mark the entire island starting from the current cell RC. And after this DFS finishes for the current island, we'll increment the number of islands counter by 1, since of course we have found a new island and we have again initialized or initiated that DFS call. And ultimately, outside of this function, I already have it, but I can return islands after incrementing it by 1 for each island we see when we actually mark land. And I can call the DFS to fully explore that island and mark all the lands of that island to be water once I'm done with that initialization, because I don't want to use land again for future iterations or future searches of my DFS, because that would actually overcount the number of islands that I have. And if I submit this code, unless I made any syntax errors here, this should be accepted. And as you can see, it's just about as efficient as you can get. So again, to kind of just overall explain what this code does, is the function loops through every cell in the grid, and when we actually find a 1, we'll start a DFS, or depth first search, to explore all connected ones, marking them as visited by turning them into zeros. And each time a DFS is initiated, it means a new island has been found, so we'll increment the island count. And after processing all the cells, the function returns the total number of islands, right? So for the time complexity here, this is going to be big O of m times n, where again, m is the number of rows and n is the number of columns in the grid, or the input, right? And that's because in the worst case, we'll visit every cell once, right? And each DFS explores all connected ones in an island, which means the total number of cells we process is m times n, right? And for the space complexity here, this is going to be big O of m times n also, because in the worst case, due to the recursion stack used by DFS, if the grid contains a single large island, the DFS could recursively explore m times n cells using that much space on the recursive call stack, right? So that's basically the solution for Leetcode problem 200, a very common technical interview question at many different companies, including the FANG companies, so it's a great problem to know how to solve, right? And it's also a good stepping stone to actually master, or at least become proficient in the DFS algorithm, right? Which is a very, very important algorithm along with BFS for graphs and matrices. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.